Welcome to my lecture on omitted measurements involving two adjoining sides. Let us now consider a closed traverse of 6 traverse stations or 6 bounding lines AB, BC, CD, DE, EF, and FA. And suppose that BC and CD are the two adjoining or adjacent sides with unknown quantities, either a known length or a known bearing. There are three possible cases that may arise regarding the unknown quantities on the adjoining sides BC and CD. 1. The bearing of one side and the length of the adjoining side, or the length of one side and the bearing of the adjoining side. Second case is when the directions of both adjoining sides BC and CD are missing. And finally, when the distances of the adjoining sides are missing. Okay, to work on the missing quantities, we can start by isolating the sides with unknown quantities, sides BC and CD. And we consider only those sides with known distances and directions. These are the sides DE, EF, FA, and AB. To start, we can construct line BD, or we connect points P and D by means of a line, and we shall be calling this as our closing line. Next, we consider track A, B, D, E, F, and A. And being a closed polygon, we'll be able to determine its latitude and departure by summing up all the departures and all the latitudes of the courses in that track and equating them to 0. So consequently, we'll be able to calculate for the bearing or direction of line BD as well as its length. Once we have done that, we can then isolate triangle B, C, and D, and we can work on the unknown quantities using the laws of sine and cosine. Let us now work on the following problem. So we have here a traverse comprising of 5 station points. The bearing of line EA and the length of line DE are both unknown. So given the lengths and the bearings of the other lines, we calculate for these omitted measurements. So as for the solution, we have the traverse and we indicate line AD or DA as our closing line. Then we shall consider track A, B, C, D. So what we do is we tabulate the latitudes and departures of lines AB, BC, and CD. From this data, we'll be able to calculate for the latitude and the departure of the closing line DA. So we get the summation of the departures equal to 0 and the sum of the latitudes equal to 0. So for the sum of the departures equal to 0, we add the departures of AB, BC, CD, and DA, equating it to 0. We'll be able to find the departure of line DA equal to 569.81. For the latitudes, we add the latitude of AB, BC, CD, and DA and equate it to 0, and we'll get the latitude of DA equal to 2283.05. Knowing the departure and the latitude of line DA, we then calculate length of CD, and the length of CD is equal to the square root of the sum of the squares of the latitude and departure of DA. So we substitute the values, we get the length of CD equal to 2,353.08 meters. As per the direction, we calculate for alpha, which is tangent or arctangent of the departure over the latitude. Substitute the values, we'll get the value of 14 degrees and 1 minute. Hence, the bearing of line DA is north 14 degrees, 1 minute east. No? It has a northeasterly direction because both the latitude and the departure of line CD are positive. Now that we have the complete information about the closing line DA, next step is to isolate triangle ADE. So in this triangle, we indicate the length of side EA as well as the length of side DA. We also indicate the directions of lines DE, north 2839 west, and the direction of DA, north 14 degrees 1 minute east. So we solve for theta D. Theta D is simply the sum of the alpha of DE and alpha of DA, which is 28.39 and 14.01 minutes, which is equal to 42 degrees and 40 minutes. Next, we apply sine law. For sine law, the side DA is to the sine of theta E, as side EA is to the sine of theta D. We substitute the values and we'll be able to find the angle theta E, which is 66 degrees and 30 minutes. So theta E is 66 degrees and 30 minutes. And from this, we can determine the bearing of line EA. So the bearing of line EA is equal to 180 degrees minus 28 degrees 39 minutes minus theta E, which is 66 degrees and 30 minutes, thus giving us the direction of line EA equal to north 84 degrees 51 minutes east. Our next task now is to determine the length of line DE. And to do that, we need to determine first the angle theta A. So theta A is simply 180 degrees minus theta D minus theta E. No? The sum of the interior angles of a triangle should be equal to 180 degrees. So theta A is just the difference between 180 and the sum of theta E and theta D, which is equal to 70 degrees and 50 minutes. Now that we know theta A, we proceed by applying sine law to lead us to the length of side DE. So by sine law, DE all over sine of theta A is equal to EA over the sine of theta D. Substitute the values, then we determine the length of DA equal to 2,423.62 meters. So our computations are now complete. We have the direction of line EA, which is north 8451 east, and the distance or the length of line DE, which is 2,423.62 meters. So here is the completed table for our traverse. Thank you for listening.